Okay, I will be presenting the ALU adder component as part of Lab 3. So I'm going to talk about the functionality of the ALU adder. The purpose of the ALU adder is to perform the arithmetic operations like addition and subtraction. It also uses logical operations like AND and OR. The first function of the ALU adder is the multiplexer, which utilizes logic gates. So you have two inputs, and in this case we're using a 1-bit ALU, and so you have the A and B inputs that is going in, and you have the operation either 0 1 as your multiplexer and outputting your result. Second function is the addition. The adder must have two inputs for the operands and a single bit output for sum. So in the case you have two inputs, A and B, which can go all the way up to 32 bits, and then you have your carry in. This is your second output, is your third input, and then you carry out as your second output along with the sum. So in order to get the carry out, we assume the carry out will be 1. So in this case you have, doing pretty much your logic gates, you have your B with carry in, or your A input and with your carry in, as well as your A and B function, as well as your AB carry in function. So in this case we're assuming that A and B carry in must be true, so carry out can be simplified down to your B and carry in with your A and carry in and your A and B function inputs. So with that said, this is pretty much this circuit for the adder. As you can see, you have your carry in, your A and B inputs. That's all AND, different combination, and going into an OR gate, which for your carry out. Same thing dealing with your 1-bit ALU. We have an A and B inputs, and then you also have your carry in. So this is combined with your ALU and your adder in order to get your result and carry out. So the main things is we're going to talk about, we're going to see when we put this into Verilog, we're going to have different sequence of your inputs as with your outputs to get the results. These are my sources. One of my source, when I pretty much put this together, get the information, and this is what I've been using to do some of my get some of my information as far as the circuitry. So now we're looking at building the ALU adder in Verilog. So what I've done is, based on the examples that I've showed you earlier, I am taking the inputs and the outputs and building the circuit so that I can get the outputs for the carry out and the sum. The one thing I want to note is on the carry out is pretty much there to go to another adder. So for instance, I'm building a 1-bit adder, but if I were to do 32 bits, each of the carry out of each of the 1 bits will go into the other adders in order to get down to my 32 bits. So in this case I have 3 input wires, that is your A and B and your carry in, and then I have my output wires, which is my carry out and my sum. So putting it all together, I come up with a couple function for my XOR, my ANDs, AND gates, and my XOR and OR based on the example that I showed you. So running my test case, I built a tester which takes all the inputs. So you look in, you carry in, I'm building one test case. I got my carry in, my A and B input, and it's supposed to display my sum and my carry out in Verilog. So jumping over to Verilog, I'm going to take both of my files, my tester file and my file that I built for circuit. I'm going to combine the two, and I'm going to compile it. Everything seems to be okay, and then I'm going to put the output. And in this case, it says that with carry in is a 0, and my A and B inputs is 0, 1. My sum comes out to 0, and my carry out comes out to 1. So if I were to look at this in GDK wave, I should be able to see time. So I'm going to take my input wires, and then I'm going to look at my output wires. Okay. And I'm going to display it, and at each of the seconds, as you can see, got 10001. You can say the time, and it's for this 1-bit adder, ALU adder. We can see pretty much the high and the low when we either have our inputs at 0, 1, and then we get our output and our sum. Some of the things that I as I kind of went through some test cases, I noticed that my sum and carry out, sometimes it did not match what my truth table should be, so I had to go back and relook at my module circuit and ensure that I had it built correctly in order to get the right output. But other than that, in conclusion, with the ALU adder, this is basically basic operations to perform the arithmetic operations as far as addition and subtraction. And as you build it either further, you can, it's a lot of AND or different type of logical gates. You have your multiplexer, and then you have your adder, and based on your different functions, you have your carry in, you have your 3 inputs and your 2 outputs in this circuit, and that's basically the functionality of a 1-bit ALU as well as an adder. I pretty much stuck with the structural flow and did my calculations with that, and so that's pretty much the functionality and design of the implementation of the ALU adder. That concludes my presentation.